Hello, welcome back to part two of rational functions. So, in part one, we covered how to find the vertical and horizontal asymptotes. Okay, so here in this video, we are actually going to do the graphing. Okay, so let's go ahead and continue on. 3.6 graphing. All right, so let's go ahead and try this first example. So let's graph r of x equals 2x squared plus 7x minus 4 all over x squared plus x minus 2. Okay, so sometimes it's good to factor everything. You don't have to, um, but I am, just in case I might need it later. So 2x, x, minus and plus, and that looks like it's going to be 4 and 1. 2 times 4, 8, minus 1 is 7. Okay. And then down here, x times x plus minus 2 and 1. All right, so this is what we have, right? Okay, so let's go ahead and find our vertical asymptotes in our horizontal. All right, so our vertical asymptote. So we see here we have vertical asymptotes when the denominator is 0. So we have it at x equals -2 and x equals +1. Okay, and then our horizontal asymptote. Okay, so they are the same degree, so I will use leading coefficient over leading coefficient. So that would give me y equals 2. All right. Okay, so let's go ahead and graph those. All right, x equals -2. X equals 1. Y equals 2. Okay, so now to figure out the rest of the graph. So what happens is um, we have these areas, these sections. Okay, so we need to figure out what's happening to the graph over here on this side of this vertical asymptote. We want to know what's happening to the graph over here on this side. And then we also want to know what's happening to the graph on this side of this vertical. Okay, and then we also want to know what's happening in the middle, in between the two. Okay, and so the way we figure that out is by making a table of values. Okay, so let's take a look. All right, so if I want to know what's going on over here, I would choose some x values that are over here in this area. So maybe -3 and -4. Okay. All right, so take your -3, plug it into here, or you can plug it into here. Either place is fine. They're both the same function. Plug that into your calculator, and we get -1.75. Okay, so -3 and then -1.75. Okay, so actually positive 1.75. Oh, no, that was right. Okay. Oops, sorry about that. My drawing is really bad over here in my notes. Okay. All right, so -3, we hit negative 1.75. Okay, so I would go ahead and plot that over here, 1, 2, 3, and I would get negative 1.75. So almost -2. Okay, and then -4, when you plug that in, you can actually see it here. -4, we get 0. Okay, so -4, 1, 2, 3, 4, we get 0. Okay, and you could do more values if you want to, but I have a pretty good idea of what's happening here. Remember, your graph goes towards your asymptote, so it should go closer and closer to your asymptote here. And then this will go closer and closer to this asymptote. Okay. All right, so we have that graph. Okay, I'm going to go ahead and let's get some points over here. So that's 1. So let's get like 2, 1.5 maybe. Okay, so let's get 1.5, 2, and 3. All right, so if we take those values and plug them in, again, you can use this function, this representation of the function, or that one. If you plug in 1.5, you get 6.29. If you plug in 2, you get 4.5. And if you plug in 3, you get 3.5. Okay, so let's go ahead and graph those. 1, 2, 3. All right, so 1.5, 1, 2, 3, 4, 5, 6. All right, 1.5, and we get 1, 2, 3, 4, 5, 6.29. Okay. So somewhere way up there. And then 2, we get 4.5. 2. Yeah, that one looks like it's over too much. Okay, 2, we get 4.5. 1, 2, 3, 4.5. And then 3, we get 3.5. Okay, so we can kind of see what's happening here. We see that it's curving like this, getting closer to the asymptotes, both of them, right? It should get closer to this asymptote, and it should get closer to this asymptote. Can't really see it up here, but there you go. All right. Okay, so we got the left side. We got the right side. Now we got to get the middle. All right, so for the middle here, let's see. 0 is a good number. -1 is a good number. Maybe 0.5. Okay, so let's do 0 and -1 for sure, and then 0.5. Okay, so I like to try to get a good span. So like we had 0 and -1. If you get a good span across here, then it will give you a better idea, because sometimes you might get a point like there. If you skew too much to one side, um, you get like these 3 points, and so you're thinking, oh, it does this. Okay, but in actuality, it does this. Okay, so you want to make sure that you get some good points that span this area here. All right, so 0, we get 2. -1, we get 4.5. and 0.5, we get 0. All right, so this here is the middle section. Okay, so 0, 2, -1, 4.5, 1, 2, 3, 4.5, 0.50. Okay, so we see here that we get, remember it should get closer to that asymptote. And then same thing here, get closer to the asymptote. So this is more of that x cubed graph in the middle, okay? Not always, but most of the time you'll get something that's very close to the x cubed graph, or you'll get something very close to parabola. They might be a little bit crooked, but that's generally the case for the middle section, okay? All right, so that's basically what you do here for the graphing. You get your vertical asymptotes, you get your horizontal asymptotes, and you get some points for each section, left, right, and in the middle, and you plot. Okay, let's go ahead and try another one. Let's go ahead and graph r of x equals 2x squared minus 4x plus 5 all over x squared minus 2x plus 1. Okay, so let's do our verticals. All right, so x squared minus 2x plus 1 equals 0. Let's factor that. X, again, you could factor up here. It doesn't matter. Minus, 1, 1. Okay, so we have a vertical asymptote at x equals 1. All right, let's do our horizontal. All right, they are the same degree. Both of them are degree 2. So we're going to do leading coefficient over leading coefficient. So y equals 2 over 1, which is just 2. Okay. All right. I'm going to go ahead and do the graph over here. All right, so we have x equals 1. We have a vertical. Y equals 2. We have a horizontal. Okay, and now we need some points. So I'll go ahead and choose some points to the left. Okay, so I like 0 and -1. Okay, so 0 and -1. When I plug in 0, I get 5. When I plug in -1, I get 2 3/4. Okay, so let's plot those. 0, 5, 3, 4, 5. -1, 2 3/4. 1, 2. Okay, so we see that it is probably doing something like this. Okay. Again, you can get more points to determine exactly what's happening over here, because if you remember in part 1 video, I said that the graph never crosses the vertical. However, the graph could cross the horizontal. So I'm assuming it's doing this. However, let me erase that. It could do this. could do that, okay? But I wouldn't know unless I plotted enough points to find the funny area that's going on here. Okay, I wouldn't expect you to do that. I would try to choose problems for you so that you're not tricked between choosing a graph that has this as an option and the one that I had earlier where I have this one also as an option. Okay, that's kind of cruel. Okay, so I will try to keep it so that it's one or the other will be an option. Okay. All right, let's get some points over here on this side, on the right-hand side. So probably 2 and maybe 1.5, something close to the asymptote. All right, so let's pick 2 and 1.5. When I plug in 2, I get 5. When I plug in 1.5, I get 14. All right, so 14. Let's pretend 14 is up here. All right, and then 2, and we get 5. 1, 2, 3, 4, 5. Okay, so we see that probably does something like that. Okay. And again, these points are points on the left of the asymptote, and these here are on the right side of the asymptote, the vertical. Okay, and let's go ahead and do one more. Let's go ahead and graph r of x, which equals to x squared minus 4 over 2x squared plus 2x. I'm going to factor it here because this one is easier to factor. That last one, I didn't want to take the time. Okay, so here they have 2x in common and x plus 1. Okay, so vertical asymptote. At x equals 0 and at x equals -1. So I got it from the denominator. Okay. Horizontal. Same degree. So leading coefficient over leading coefficient. So 1 over 2. So remember, if the degree is smaller up here, it's just going to be automatically at y equals 0. Okay. I guess I should have done an example like that, but I didn't. Okay. Let's go ahead and graph our asymptotes. All right, x equals 0. You know what? Let me do this. I'll use a different color. That way you can see it here. Okay. X equals 0. X equals -1. Y equals 1/2. Okay. And now we will make our table. So all right, so let's get the left side, middle side, and right side. So left side, left of -1. So let's choose -1.5 and -2. All right, so if I plug in -1.5, I get -1.2. If I plug in -2, I get 0. All right, so let's plot that. -1.5, I get -1.2. And -2, 0. Okay, so I get something like this. Again, if you're ever unsure, then just plot more points. Okay, let's do the middle. The middle. Ugh. Okay, so -1/2. Let's also do, we don't have great choices here. So -0.5, -1/4, and -3/4. All right, when I plug in -0.5, I get 7.5. When I plug in -1/4, I get 10.5. When I plug in -3/4, I get 9.2. All right, so let's go ahead and plot these. These are way up high. We have one. Okay, this is way up high. All right, so -1/2, we get 7.5. -1/4, we get 10.5. And -3/4, we get 9.2. So we get something more like the parabola in the middle instead of the x cubed graph. Okay. Let's get the right side now. So this was from the left. These are for the middle. And now let's get some for the right. This is nice. We have choices here. Let's do 1/2 and let's do 1. All right, when I plug in 1/2, I get -2.5. And when I plug in 1, I get -3/4. So -1 and +1/2, I get -2.5. And 1, I get -3/4. So it looks like we're doing this deal. All right. Excellent. Okay, so that is basically how you do the graphs of rational functions. It'll take some time because you're going to be making a table of values to figure out the behavior, especially if you have a middle area like this, it will take longer. But if you just have a left and a right, it's not so bad. Okay. All right. If you have any questions, make sure you message me. That does it for chapter 3.